Hello and welcome to this lecture AWS Storage. So I made this video because I saw your comments and a lot of people who watched my earlier videos wanted to have overview of AWS storage services and in particular the difference between various storage options that you get in AWS. And typically that's between EBS, that is Elastic Block Storage, versus S3 versus EFS, Elastic File System. So in this video I'm going to cover a basic storage high level overview, and then hopefully you'll be able to map your use cases to a right storage option in AWS. So what we are going to discuss in this video is about storage options in AWS, where in the architecture they fits in, typical use cases for different storage options, then the characteristics of the storage with respect to availability and durability, performance, cost, and then how to make a decision on choosing the right storage options. And finally, if you get this video right, you should be able to complete a knowledge check. So let's get started. Now, if you have already watched my video, I have talked about few of the storage services. So in this video, we are going to talk about EBS, Elastic Block Storage. We are going to talk about S3, Amazon Simple Storage Service. We are going to talk about Elastic File System and then the variant of it, that is FSx for Windows. So don't worry, I'm going to talk about all these services shortly. So again, if you watched my introduction to AWS services, I had presented this architecture, and that's a simple web application where you process the images and a lot of other use cases I talked about. And during this video, I also talked about using EC2 machines as your web server and application servers, and then somebody upload the pictures. That pictures may go to some AI service to find out if there is something bad in the picture. And this pictures needs to be then stored in the storage, which can be accessible directly from the web users or a mobile users, right? And here also we talked about some storage service, if you remember. So just to recap, we talked about a storage which is local to the EC2 machine, like you have a laptop and you have a disk. That storage is EBS, Elastic Block Storage. As the name suggests, it's a block storage, right? Even the database needs a block storage to get access to the data really quickly. And then we talked about a storage which can be accessed over the internet, right? And that storage in AWS, we talked about S3 there, right? So these two storage we talked in brief, but there is one more use case. For example, somebody has opened the web application and he wants to edit the image. Now that image could be in this EC2 machine or this EC2 machine. Now somebody can't edit the image which is there in the S3 because he has to then download the image, edit and then upload. And I'll talk more about why that's the case. So typically the image which is available for editing should be there on this EC2 machine. Now you can understand, like, you know, this is a highly available architecture. That means your request might go to this EC2 instance or this EC2 instance. So for this kind of use case, you need a storage which is shared between these two EC2 instances, for example, right? Now EBS, you can say it's a per EC2 instance. So EBS data here cannot be accessed by this EC2 instance. That means if there is an image into this block, it cannot be accessed from this EC2 machine if your request to edit the image goes here. So we need a better storage, better as in which is shared between multiple EC2 machine, and that's the EFS, Elastic File System, right? And we are going to talk more about that shortly. So at high level, at architecture level, what I want you to take away is that EBS, something which is attached to your virtual machines, S3, which is a standalone storage which can be accessed over the internet, and EFS, something which is shared between multiple EC2 machines or multiple VMs per se, so that all VMs can access same data at the same time. So that's about these three storage options. So again, what is EBS? Now, if we talk about the definition, EBS is a block storage, which means that data is organized into a unique block, right? Like in your hard disk, and whenever you retrieve some data, right, that data is there in this hard disk and it is accessed depending on how you store the data. So it's a block storage, and your host file system, now that depends on which file systems you install. Like if you are using Linux system, you might be having ext4 kind of operating file system on top of it. So it accesses the underlying disk, right, or a block storage to get the required data, right? And EBS must be attached to the EC2 machine. As I said, you can't standalone use the EBS volume. For that, you must have this volume and must have EC2 machine which is running, and then through this EC2 you can access this block storage. So examples would be ZFS, ext4, or other file system on top of the your block storage. Now, what is S3? It's a simple storage service, but what does that mean, right? Now you can see S3 is more like, bucket or a container which has the objects in it. And what you do is typically you get the object or you put the object. That means you write the object as a whole and get the object as a whole. So if you want to operate on this particular file, you first get this file out, you edit it and dump it back, right? You can't edit this in place there because it's object storage. You consider it as a bucket, and in the bucket there are balls, right? You get the ball, you do whatever you want, and you put the ball back into the bucket, right? So that kind of storage is S3. And the best part about S3 is a flat structure hierarchy. Like, it's not like there is a root directory, and then inside root directory there are multiple folders there, and inside that multiple folder there are multiple folders. It's not like that. That means all the objects in the S3 are at the same level, right? It's a flat hierarchy. Even though when you browse your S3 data, you might see folders, right? But those are not actually the folders. Those appears like that, but ultimately every object has a unique name, and it is a flat hierarchy. That means all are at the same level here. And the best part about S3, they are accessible over the API call, unlike your block storage where it should be attached to EC2 machine to get the data out or in. Here with API call, you can put the data and get the data, and that's the one of the biggest benefit, right? You can host your pictures and images and everything into the S3, and from your browser or a mobile app you can directly get that data. For that you don't need to ask for the data to your web server or app server. You can directly get it here, right? And it's a metadata driven. We'll talk more about S3 maybe in the separate session where we'll discuss only about the S3. But then this object has attribute and policies, who can access data and who cannot. All that comes with the S3. Now third option is EFS. As I said, it's a hierarchical file systems like root directory, and then there are multiple subdirectories and then subdirectories kind of thing. But the best part is this is a shared file system. That means one EFS can be mounted on multiple machines at the same time, and all the machines would see the same data, right? So it's a shared file system. It comes with its own serving file system, right? Using protocols like NFS you might have heard, or SMB you might have heard, right? It comes with that. And it should be mounted, as I said, on multiple EC2 machines or on-premise machines at the same time, so that all can access the same data. So technically there is a difference between the how these volumes and storages are used, and these characteristics will actually define the use cases for these storage options, and we will see that shortly. Okay, moving on. So on architecture side, we talked about architecture earlier, but let's deep dive there, right? So EBS has a scope at AZ level. That means if you have an EC2 instance, then you will create a EBS volume into the same availability zone and will attach it to that instance. Now this volume cannot be attached by this instance because AZ is different. That means the scope of EBS volume is AZ level. And then there is no limit on how many volumes typically you can attach to your EC2 instance. Like you have a C drive and a D drive. Similarly, you can have multiple EBS volumes attached to the same EC2 instance, and then you can write data to those drives there, right? So that's typically EBS. You create EBS in the AZ and attach to EC2 instance, and that's it, right? Then comes S3. Now here you can see there must be an EC2 instance. Now this EC2 might have its own EBS volume, but for use cases like storing picture and videos, you don't want to store it here, right? You want to store it in S3 because this data can be accessed by the external world directly over an API call. Now even this S3 is if you see, it's in a region, right? But it's not within the particular AZ. The scope of S3 bucket is regional. And then even EC2 needs to access data. It needs to access over an API call like HTTPS. So instance need to have connectivity to the S3 over internet. It goes through the IGW typically, and then you can access the data. Now best part is, as I said, S3 data can be accessed over from the internet. Now if there is a user sitting here, right, and he opens the browser and takes to AWS console or S3 URL for that particular image, he can see that image if he has permissions directly. Now your request is not really going to EC2 and then EC2 fetching the data. Your request, it's directly going to the S3 to get the data, right? So that's S3. And as I said, S3 is a regional service in the sense that your bucket which holds this data is in the region, but it can be accessed from anywhere because access is over HTTPS, which also means you can access data from any bucket in any region. So in access way, it's global, but in order to store the data, it uses the bucket, but those buckets are regional. That means bucket would either reside in, say, US East 1 region, North Virginia, or say a Mumbai region or any other region, right? But it can be accessed over HTTPS from anywhere. So that's S3. Next, architecture about EFS. As I said, EFS is a shared kind of file system. Now, EFS scope is also regional. That means you have a VPC, you have multiple availability zone, and you have EC2 machines inside this. Now, what you can do, you can create an elastic file system across multiple availability zone, and then you can mount this into EC2 machines, right? It does not matter in which AZ your EC2 instances are. You can use your elastic file system, and whatever files are there, both EC2 would see these files at the same time, and they can modify these files as well. So that's EFS. And the good part about EFS is that if you have your on-premise instance, which has NFS client, you can also mount it there. If EFS allows, EFS endpoint allows mounting, meaning you have the connectivity as well as permissions, you can mount this here, and the same file can be looked at by the on-premise servers as well. And there are certain use cases in which you would want to do that. So typically this is the architecture of EBS, S3 and EFS. So I hope that is clear. Okay, so what are the use cases, right? We talked about the basic characteristics, where what defines these storage types and what the architecture should look like. Now use cases, if I talk about EBS, it's attached typically to your VM. That means it provides you the lowest latency to your data. Right, it is typically the SAN, it is called as SAN, but it is something different how AWS built it, storage area network, and it provides you the lowest latency access to the data. So that's where if you want to host an operating system or a database which requires very low latency access to data, typically you would host that in EBS, typically, or say always, because other storage options are not good for hosting a database or an operating system. And that's where your boot volume or databases you will see typically on the EBS. And that's where it makes sense to use EBS for broad range of categories. Maybe it's databases, Microsoft SharePoint, SAP ERP, Oracle ERP, because these systems need access to the local data really very fast, right? So that's EBS use cases. Now let's talk about S3. It's unlimited space, virtually unlimited space. That means you can store as much data you want with cheapest cost, right? And that's where they are stored for media and entertainment. Now, I don't want to quote a particular company, but just an example, if it's a Netflix, for example, and they have thousands of videos, right? Where should they ideally store it, right? It should be typically in S3, and from there your videos can be seen on your browser. Of course, your video has to be converted using the media encoders and all, but that is an appropriate storage for your videos. Same for your images, same for your log files. If you want to store all your machine log files somewhere securely, or backups of your data, that's typically your S3, right? Content management system, version control system, because S3 provides ability to version control, right? You can have multiple versions of the same files. So S3 can be used for that as well. So you can think of a storage, durable, reliable storage, which is external, which can be accessed over an HTTP and API call. Think about S3 in that case. But the downside is, the anti-pattern is you can't have low latency access to the data like a block storage, like a EBS. So you can't host, databases or operating system there on the S3. Now, third kind is EFS or FSX. Now, EFS, FSX has similar properties, just that FSX supports SMB protocol, which is typically used for Windows or say non-Linux systems. Mac supports that, Windows supports that, but otherwise all the characteristics are almost same. So shared access to the files, web serving, the example that I had given, right? You have fleet of web server and you want to edit a file. Maybe all web servers should see the same file because request might go somewhere, right? So that's one case. Big data and analytics, because in big data typically you have to do a lot of transformation. So there is a workflow, for example, where first machine transform the data into one format, then next machine picks up and do something else. No, rather than moving the data from one machine to another machine over the network, rather you store the same file in the EFS, and then every workflow machine would pick the same data from EFS directly rather than exchanging the data over the network. Users home directory, that's another good use case. Content management, container storage, that's because containers are typically come up and go back, right? Now if you want a persistent storage for container, it's difficult to have EBS where every time you will mount the same EBS volume for the same container. So rather you use EFS so that if new container comes in, it sees the same data as what other container had stored earlier. So that's another use case for EFS. Typically Kubernetes system uses EFS for container persistent, as a container persistent storage. Availability and durability. Now let's first understand what does that mean, right? So here is a chart. When we say availability and durability, these numbers provides the percent. When you say something is available 99.999, which means it is available, downtime is only 5 minutes, 15 seconds, an year. And as you go, you can read about more, right? Durability is what are the chances of losing some object or some file. So depending on this number, you can see 1 in maybe 100,000. When you say durability is 5 nines, this is 6 9, this is 7 9, and this is 11 9. S3 provides you this kind of durability. I can't read this number, but that's the robustness it provides when somebody says it's 11 9 of durability. Okay, so let's see how these storage options provides you availability and durability. So if I talk about say EBS, it provides availability within the AZ because scope is AZ level, and it provides 5 nines of availability within the that particular AZ, and they're designed for 99.8 to 99.9% durability depending on which EBS volume type you use. Now there are multiple volumes types like GP2, IO1, IO2, but we'll talk about that maybe in the EBS session separately. Now S3 provides you availability of 4 nines, 99.99 for standard storage, and it changes depending on storage classes of S3. We are not going there. And it is designed for 11 9 of durability. Again, that depends on your S3 storage tier. There are different, but that's what the durability it can provide. Now EFS is highly available within AWS region, and it is typically designed for similar durability like S3. There are no numbers put on there on the AWS website per se. So performance wise, first thing you should know is what defines the storage performance, right? So storage performance is defined by IOPS or IOPS, throughput and latency. Now what IOPS means? Input output operations per second. How many operations you can do per second. Now throughput is how fast storage can be read and write. Typically IOPS multiplied by the size of the data in one operation. For example, IOPS is 3000 and in one operation you can read say 1 KB of the data. So your throughput will be 3000 into 1 KB, right? That is 3000 kbps. So that defines the throughput. And the latency is time delay between request of the data and response of the data. Now that would also depend on where your storage, where your compute, and how the network looks like and what the underlying protocol you use to access the data. So these three parameters would define the performance of your storage, right? Now this is how throughput and latency looks like for block storage, file storage, and object storage. So in terms of latency, block storage are the fastest because they are block storage. First of all, data is stored randomly into the blocks, and then you can pick any block randomly, and it is typically a SAN kind of thing, right? That's where it's the fastest. But throughput wise, you can only attach it to one EC2 instance or one VM typically at a time. So throughput is as much your machine can read. That's it, right? Now if we talk about the file storage, like an shared file system, for example, it has different protocols. So latency is somewhere in the middle, but multiple machines can get the data at the same time. So aggregate throughput typically increases for this. And same with the object storage. It is access to our API call, right? That means there is more, it's layer 7 protocol, and then you have to get the data and do a lot of things there. So latency would increase. You can't access directly the block there. You have to get the whole file. But the good part is multiple clients can read the data at the same time, right? and that's where aggregate throughput for file storage and object storage is high as compared to the block storage. Now in terms of AWS, block storage EBS, file storage we are talking about EFS or FSX, and object storage we are talking about S3. So in terms of performance, you will see this three storage option placed here, right? And you can then think which storage option to use given the requirements. So cost wise, again, S3 is the cheapest, pay as you go. That means you don't have to pre-provision the capacity. As much you will store, you will be charged for that. S3 has multiple charges, typically per GB per month charges. It's just an example. And then also it charges based on number of requests. So 0.005 per 1000 requests. Now that's in North Virginia, and cost may change for other regions. But S3 has storage charge as well and API access charges as well. And it is the cheapest storage. Now if you go to Glacier, which is for archival, it has much cheaper cost than the S3. EBS higher than S3 of course, but you have to provision the capacity upfront, right? You can't say I'm just storing 1 GB of file, then I should be only charged for 1 GB. No. In EBS, you have to first provision volume of say 100 GB, and you will be charged for that 100 GB whether you use it or not, because it is attached to your EC2 machine. It's not elastic in that sense, right? So you pay for the provisioned capacity, not as much you use. And it is like $0.1 per GB per month for that EBS volume. Now EFS has highest charge among three. Again, it's pay as you go. It has characteristics similar to S3 and similar to EBS. It's somewhere in the middle with respect to characteristics, but the cost wise it is higher. So pay as you go, that means you don't have to pre-provision the capacity, unlike EBS. It is more like S3 here, and the charges is per GB month, like 0.3 per GB. But that does not mean EFS is always costlier than EBS. Now imagine there are 3 EC2 machine accessing the same data at the same time, right? Versus 3 EC2 machine having separate EBS volumes attached to them. Now this cost will be triple, right, in that case. So depending on your use case, EFS can be more cost efficient than EBS, right? If there are hundreds of machines accessing same data at the same time. So you would have to do all those cost analysis before deciding what is more cost efficient. But typically decision is not only on the cost, it is more on how you access the data. That would define which storage options you want to choose. So the decision tree, I try to put all things together to help you. How do you basically decide whether I am to go with EBS or S3 or EFS or FSX? So let's see that. Who need access to the data? Does EC2 need access to data, or from anywhere I need access? So let's take, I want to access data from EC2 machine. Now what is the data access pattern? It's write heavy and read heavy. That means you are continuously writing and reading the data, like operating system or for databases. That's typically this case, right? If that, then obviously we are talking about block storage, because we are reading and writing heavily. And then there is a choice. Do I need to persist that data, or it is okay to lose the data? Now why we are talking about that, EBS or say block storage comes in two flavors in AWS. There is something called instance store volume, and then there are these EBS volume. Now we haven't talked about instance store so far, but it is something you attach this volume to EC2 machine, and if you restart your EC2 machine, data will be wiped out. It will be completely gone. So if you don't need a data to be persistent, you go with instance store volume. If you need your data to be persistent, you use elastic block storage. Now instance store volumes also has a lot of restrictions, and we'll talk about that maybe later. But typically for read heavy and write heavy, the choice would be EBS, right? Because mostly people want to persist the data. Then comes if your data access is write once and read heavy, right? Just you write once and read, like data analytics kind of workloads, right? Then it goes around the file storage. And in file storage, does your application support integration with S3? That means can it go to the S3, write the data there and read the data from the S3? Is there that kind of application you are developing, like photo saving or something? Then of course, if not, then which operating system your EC2 is using? Is it a Linux system? If yes, then you will go with EFS. If it's a non-Linux system like Windows or Mac, you will go with FSX. Sorry, the spelling was wrong, but it's FSX. So that's about you're using the EFS or FSX. Now, as I said, if your application supports integration with S3, that means rather than using the EFS, probably you will go with S3 there, because S3 is much cheaper and it provides similar characteristic of EFS. So that's S3. Now, if you need access to data from anywhere, like you want to see the picture right from the browser or mobile app, right? Anybody on the internet should be able to access data directly. In that case also you will be using S3. So that's a simple decision tree, which actually with respect to how data is accessed and what kind of machines you have operating, you can decide which is the right storage for you. Now I hope I tried to talk about a lot of things there and you are able to get something out of it. So let's do a quick knowledge check here. If you want to host operating system or databases, which storage you will use? So I can hear you are talking about EBS, and that's right. Distributed computing. Now distributed computing means what? There are multiple compute machines and all these compute machines need to access typically a same kind of data at the same time, or they need to process data and reprocess data in the workflow fashion, right? Then it is typically EFS, multiple machines are accessing data at the same time. Now there is a dotted line to S3 because in some cases you can also use S3, and that would really depend on your use case. So we can't say just an EFS, but EFS should be first choice, and then you should also look at S3. Social media and images, videos, it's obvious it's S3 because all these video images should be accessible directly over an API call. Media workflow application is more like, you got an image, now you do a processing of that image and you have multiple jobs running. Maybe a first job just changes the size of the image, a second job changes the color of the image, whatnot, right? So same file, but then multiple operations on that file over the time. So rather than exchanging the file, you just have the common and shared storage and you just do that operation on that file. That's EFS, right? Low latency data access, of course, it's EBS. Hosting static website. Now that's interesting. What does static website means? It's just typically an HTTP based website. Now in this case, data should be accessible over an API call, that means, and it should serve HTTP or HTTPS traffic. So rather than storing it on EBS or EFS, you should store it in S3, because for EBS you need an EC2 machine, but I'm storing a static website. I don't need an EC2 machine, and I shouldn't be paying for that additional cost. Same with EFS. I don't want to pay for server which will access data from EFS and then will give me that data over a browser. Rather, I can directly store it in S3 and access over a browser. So it's a most cost efficient option for hosting a static website. Least storage cost for backup, archival, long-term storage, right? I don't want to look at that data for 7 years. Of course, there is an S3 and there is an S3 Glacier. Actually, that's a write storage, but just for simplicity, I'm showing it as S3. Then container persistent storage, we talked about that. Container are like, they die and come back at any moment of time. And if you want to store something persistently and make sure the next container which comes up has the access to the same data, of course, it would make sense to have EFS in that case. And there is a dotted line to EBS depending on your use cases. Storing raw data at scale, that means unlimited, cheapest, right? And that's a data lake concept. Basically, you get everything that you have, data sources from multiple social media feeds and clickstream analysis and everything. You put that data at one place, and then you, on top of it, you do a machine learning and data analytics. If that's the use case, it is S3. It should be S3. S3 is designed for that, for data lakes. And then exchanging data for analytics and machine learning between different organizations. So I have data here, you take my data. How do you share the data between other organizations? Now that could be on, that organization may have their workload on AWS or may not be on AWS. So ultimate need is to have that data accessible over an API call. What does that mean, right? So again, it should be S3, right? You can store the data over HTTPS. So that's it. I think if you could relate these use cases to the storage options, probably you are good on understanding what the storage options are there in AWS. So with that, I hope I tried to make everything clear around storage. If you like this video, please do go and subscribe and share this with your colleague. So that's it about this. In next storage series, we'll see more about S3 and EBS and EFS, FSX in more depth. But as of now, that's it I have. So thanks for watching and see you in the next video.